Hello, sir. You are in mute, sir. Hello. Your voice is not audible.
Yeah. Thank you. So now if I am audible,
Yeah, sir. Now it's audible.
yeah, and my screen is visible
Yes, yes,
as
sir.
well.
Yeah.
Yeah. So good afternoon, everyone, and welcome to Dr. Diabati Vidyapit Center for Online Learning. I'm your faculty for this course, that is OMBAIML 303 and OMBBA 305, that is Performing Analytics with Python. Actually, I have started this unit 2, that is Python Advanced Concepts, in the last session, but somehow the elements of this second unit are not covered. So I would like to cover those the elements, like the fundamentals of data manipulation with Python, RDBMS, and UML. But before that, I would just go through the content which I have already covered in the last session. So just for the sake of continuation, I am going through the content which I have already discussed in the last session. So this is unit number 2 of OMB AIML 303 and OMBBA 305, that is Performing Analytics with Python, unit 2, Python Advanced Concepts. So basically, if you see the content of this unit are mainly, that is, images which which consist of classes, tiled images, acceleration, fundamentals of data manipulation with Python, how to perform data manipulation using Python. I will demonstrate it practically. Then we'll see the fundamentals or the concepts of RDBMS, that is Relational Database Management System. How we can able to open the database, how we can connect to the database, how we can create a table, and how we can insert the table, that I will show you practically by using the Google Colab. Then we will discuss about the UML, that is Unified Modeling Language. What is the importance of UML and where UML is used? So this is all about the agenda for this second chapter. So basically, if you talk about the game development, the images are very essential. When you're thinking about the game development, images are the excellent way to represent different visual aspects in a game. So in a game development, images are very, very important. They play very important role. For examples, images can be the characters, it can be the objects, it can be the backdrops, or user interface elements. So all these are, we can consider as the images. So when we are developing a game, then we need to interact with these images, which can be characters, which can be the objects, or which can be the backdrops, or which can be the animations. So these are some examples of images, that is characters, objects, and backdrops. And images will make your games aesthetically pleasing and effective. Here we are discussing some of the important elements of picture management. So whenever we are dealing with pictures, whenever we are dealing with the images, so these are some of the elements that we need to know. The first thing is the visual assets. So game developers uses the images, also known as the visual assets or sprites, to depict or to represent everything within the game world, from characters and enemies to items and scenery. So first thing is that the game developers uses the images, which are called as assets, that is visual assets or sprites. So first element is the visual assets. Second one is the graphical libraries, which are used to manipulate those images. So game development often involves the use of graphic libraries or a framework that provides the tools and functions or methods for loading the images, for rendering the images, and for manipulating the images. So for loading, manipulating, and rendering the images, we need to use the graphics libraries. So for example, the popular graphics libraries includes the SDL, Pygame, and Unity's 2D engine. So these are some of the graphics libraries which are popular one, which are used whenever you are developing a game. So in order to load the image, in order to render the image, and in order to manipulate the image, we need to have some functionality, some methods, and those functionality and methods are being provided by the use of graphics libraries. So basically, graphic libraries contains the functions, the methods, and the classes which can be used for loading the graphics, for rendering the graphics, and manipulating the graphics. The next element that you need to know as a game developer is the resolution and the quality. So the game graphics need to be tailored to the target platform and screen resolution. So whenever you are developing a game, we need to understand on which platform, on which operating system that you are going to deploy your game. So to understand its graphic resolution, to ensure that they look crisp and appealing. So we need to understand the platform on which you are going to deploy your software or your game application, so that you ensure the resolution and quality of your images are crisp and appealing. So the developers often use or often create multiple versions of the images to support different screen size and resolutions. So we don't know that where what screen size or what screen resolution that the user is going to use. We can decide the platform, whether it is a Windows XP, whether it is a Linux, whether it is a Unix. We can decide the platform on which I'm going to install the target operating system. But having said that, I cannot decide what is the screen size of the user's window, whether the user is actually using it on mobile phone or using a palm top or a laptop or a desktop. And again, what would be the resolution of those screen. So in that case, that's why the game developers, they create multiple versions of the images so that they can support the different screen sizes and different resolutions. So resolution and quality is again one of the important aspect of game development. Now the second concept which is important in this game development is the classes. So if you are familiar with C++, if you are familiar with any object-oriented programming paradigm, it could be a C++, it could be a Java, it could be a Python or any other language which supports the object-oriented concepts like class, inheritance, abstraction, polymorphism. They are called as object-oriented programming language. Now, what is the use of the concept class in game development? See that basically the class commonly used to structure the code into a reusable design or a blueprint for the object in the context of computer programming or image processing. So the class will let you to structure, to group together the functions and the properties or the attributes of a specific object into a template that is reusable, and that I can create multiple objects once a class is been created. Say for example, if I have created a class called as a dog, class dog. Now in that I will define the attributes like The dog has four legs, two eyes. The dog has a teeth. So these are the attributes. Color of a dog. After that, I can define the methods or the functions of that class called as dog. So, for example, sleeping, eating, running, barking. These are the methods that I can define into that class called as a dog. So once you define the class dog, after that you can create multiple objects from this class called as dog. Say for example, I can create an object called as German Shepherd. So once the class dog has been created or any class has been defined, you can create n number of objects from that class. What is the benefit? The benefit is that you can structure the methods. You can you can include the methods and the attributes together as a single unit into the concept called as a class. And this is reusable design. Means what? Once a class is been defined, I can use that class in multiple locations or in multiple ways for creating the objects of that specific class. In the same way, if I create a class called as say fruit, I can define its attributes like color, size, and taste. Now I can define its methods, that is the availability of that fruit. So once you define the class called as fruit, now you can create any objects or n number of objects from that class called as say fruit. I can create an object mango. I can create an object say banana. I can create n number of objects once a class has been defined. So class is a blueprint. Like I always said that class is a blueprint. It's a virtual entity and the objects are physical reality. Listen carefully. Class is a virtual entity. Means what? We are virtually defining the class. But when it comes into existence, when you create the object of that class, then it comes into existence in the form of an object. So that's why a class is a virtual entity, whereas its objects are real entity, physical entity. So the term classes commonly refers to a method of structuring the code into reusable design. Like an architect designs a building on the paper, that you can call it as a class. But when the builder will actually build the building by using that template, by using that design, by using that blueprint, now we can call it as the object of that blueprint or of that template. So now we can see that whatever design the architect has drawn on paper is a class that is virtual. It is present in only in virtually. But when the builder actually construct a building by considering the design of that building, of that template, then it becomes an object. So once a blueprint is defined, a builder can build n number of buildings from that template. So that is the advantage of defining a class, which is referred as a method of structuring code into redesignable or reusable designs or blueprints for objects which can be used, which can be referred in the computer programming as say object oriented programming, and which can the concept of class can equally used for image processing as well. So classes can be used to represent many types of image related objects or actions in an image processing. So we can represent the real life images of objects and their related actions in a single unit called as a class. That is the advantage. So you may have classes for photos, you may have classes for filters, you may have classes for image processing techniques as well. So we can create the classes for n number of reasons. And classes make your code more logical and maintainable by helping to encapsulate the data and the operations together in an unit. So when you define a class, it is very easy to maintain the code. How it is possible? How it is helpful? Because when you are defining a class, you are encapsulating the attributes and its methods together in a single unit. Like I said that a class called as a dog. So in that we are having the attributes, common attributes of a dog and the common methods of a dog. So now the methods which acts on those attributes, they are clubbed, they are binded in a single unit called as class dog. So in that way it will be easier to maintain the code. So this is about a class, which is an important aspect when you are developing a game. Now we will see the next concept is the tiled images. Tiled images are made of smaller regular sized images which are arranged in a grid to create a larger image. So every small image, every small image, when you combine them together, it will create a larger picture. So this is an approach which is often used in a computer graphics and game development environment to efficiently render the large or the seamless textures, the large picture, whereas each tile, each small tile can be thought of as a smaller picture, and when combined, they form a larger and more complex image. So this is often used in game development or in a computer graphic, that is the concept of tiled images, whereas each image is itself a smaller image which is arranged in a grid manner. And when all these images are grouped together, we can render more larger image seamlessly. So when they combine, they form a larger and more complex image. So this is the important concept when you are developing a game, that is tiled images. The next point that you need to understand when you are developing a game is the acceleration. Acceleration refers to the change of velocity of an object with respect to the time. It can be the vector quantity, it can be the speed of the object, which can be referred as the acceleration. So basically, it's a vector quantity, meaning it has both magnitude and direction. But in physics, acceleration occurs when an object is moving, when an object speeds up, slows down, or changes the direction. So acceleration is also an important aspect in game development to create the animation effect in your game application, which refers to the rate of change of velocity of that object with respect to the time. That is called as acceleration. So basically, it's a vector quantity which has both magnitude and direction. So this is an important, one of the important aspect of game development. So in the context of images, acceleration might not directly apply, but it could be used symbolically to describe the speed or the efficiency of the image processing algorithms. So basically, it is used for processing the algorithms, to measure the processing algorithms for the game development. For faster image processing algorithms are often referred to as accelerated. So the image processing algorithm, which is faster, is referred as the accelerated image because they can perform the task like filtering, resizing, or recognition more quickly. So this is in case of images, the acceleration might not directly apply, but we can use it symbolically to describe the speed of image processing algorithm. And the faster image processing algorithms are often referred to as accelerated, which can perform various tasks faster, like filtering, resizing, or recognition more quickly. So this is all about the theory part of the game development. Now we'll come to the practical aspect of data manipulation, that is fundamentals of data manipulation with Python. How we can perform data manipulation using Python. But for that, we need to understand the Python, the basics of Python. So for example, its data structures that we have already covered. Now we'll see the steps which are required or which are performed for data manipulation. Say for example, for cleaning the data, for removing the duplication rows, or for identifying the missing values, or for uh, reshaping the data, changing the categorical values into numerical one, or for plotting the data visually by using the various tools like matplotlib. How we can do this? So all these things referred as data manipulation. So let's start with this data manipulation with Python. So data manipulation with Python involves the techniques for pre-processing like cleaning, transforming, analyzing the data to draw the insights and make the informed decisions. So it provides many libraries such as NumPy, Pandas, Matplotlib, which are commonly used for these tasks. NumPy stands for numerical Python, which offers the functions for performing the numerical operations on the data. Pandas will also provide you the functions for data manipulation. So the pandas are been they are been developed over the NumPy. So automatically when you import pandas, we don't need to import NumPy as well because pandas are developed over the NumPy. So first thing is that we need to know the data structure in Python. So it is important to understand the common data structures used for data storage and manipulations. First one is the list that I have already covered in the first unit. So what is a list? List is the ordered collection of elements allowing for duplicates and modifications. But it's a linear collection of elements. List is a ordered linear collection of elements which allows for duplicate. So we can store the duplicate values in the list. Next, data structure is the dictionaries. If you want to store the values in terms of key and value, I can go for using the dictionary data structure, where you can store the values in terms of key pairs, key and value pairs, for storing and retrieving data quickly. The next data structure is a tuple. Tuple and list are same, but tuple is immutable. List can be changed, list can be edited, but tuples cannot be edited. Once you insert the items inside a tuple, you cannot modify the items which are previously stored in tuples. Why? Because tuples are immutable, lists are mutable. So immutable ordered collection often used for the fixed data. So once you enter the data, you cannot change the data later on as tuples are immutable. Now, we have started with this NumPy for numerical data. That is, NumPy is a fundamental library for performing numerical operations in Python, which provides multidimensional array object called as numpy.nd array that allows efficient computation with large data sets. So the NumPy array, that is called as the numpy.nd array, ND array, by using which we can create the arrays in order to efficiently perform the computations with large data sets. So that is NumPy, which stands for numerical Python, which provides the operations for creating the arrays and performing the computations on those arrays so that I can perform computations with large data set. So now I will move on to the practical part. I will show you the practical part here. I will change to Colab library and tell me guys that if the screen is visible to you or not. Yeah. So learners, is this screen is visible to you? The Colab page is it visible? Please confirm the chat box.
Yes, sir, it's
Yeah. So now this is the example of creating a NumPy array. So here first thing is that I need to import NumPy. NumPy is the library. So import is the keyword. NumPy is the name of the library that I want to import into my code. So import NumPy as NP. You can give any name here. You can write any name here. If I can write say X, you can use X, which represents now as NumPy. Then here I have imported the statistics so that I can perform some statistic operations, like I can find out the mean, I can find out the standard deviation, I can find out the median. So for that, here I have imported the statistics library. So import statistics will import all the statistical functions which are defined in the statistics library. So after that, here I am creating the NumPy array by, as you can see that here, NP represents NumPy. So if I say np.array, in the bracket, I'm provided here the list that is in a square bracket 1 comma 2 comma 3 comma 4 comma 5. So after that, when this statement is executed, now it will create a NumPy array with the name data. So in order to create an array, we just need to provide the list of values to the np.array function. So array is the function of the NumPy. So now an array is created here with the name data. Now I can perform the operations on that NumPy array. For example, if I want to find out the standard deviation, I can say numpy.std. Std is what? Std is a function which is already defined. I just need to call, which is defined in the statistics library, which I have imported here. So now I can say std underscore dev is equal to np.std. Okay, sorry. The std function is been defined in NumPy library, not in statistics. As you can see here, the object name is np.std. Std function will calculate the standard deviation from this data array. So this statement will give me the standard deviation of 1 comma 2 comma 3 comma 4 comma 5 array. So the same here, I am just printed with the help of a print statement. As you can see here, print standard deviation comma std underscore dev, because here whatever the result which is been given by this np.std is been stored in std underscore dev variable. So now I can print its value with the help of a print statement, that is print in double quote. Whatever string that you want to display should be written in a double quotes. And if you want to add the variable's value, it should be separated with a comma, and you have to give the variable name in which the standard deviation has been stored. So here it has been stored in std underscore dev. So this statement, this printf statement will print the standard deviation from the data array. Now you can see that here I want to print the mean. How I can print that? By using the statistics library. For example, if I say here print mean statistics dot mean, and I have to provide the array name, that is data. So this statement will give me the standard mean. And again, I want to find out the median as well. So mean, median are been defined in the statistics library. So that's why here I have imported the statistic library. And with the help of that statistic library, I'm calling the functions of that statistic library, such as the median, such as the mean. So if I say here statistics dot mean in the bracket data, so it will provide the mean of the data, and I can print it with the help of a print statement. So if I can execute it, I will show you the execution one more time here. You can find that the mean is 3 and the standard deviation is this value 1 point so and so, and the median is this one. So this is a simple example of creating a numpy array and performing some operations on that numpy array, like finding the standard deviation, finding the mean and mode. So I hope you guys have understood how to create the numpy array. The next concept is pandas. Pandas are used for the data manipulation. Pandas are built on the top of NumPy. Means what? I don't need to import the NumPy if I import the pandas, because when you import pandas, ultimately, indirectly, all the libraries of NumPy are been available through pandas library. As you can see that here, import pandas as PD. Now I can manipulate the data with the help of the libraries present in pandas. Like, say, for example, first I am creating the data frame. How I can create a data frame? I just need to call the data frame function of pandas library, that is pd.dataframe. In the bracket, I need to provide the data. So basically here, as you can see, data is equal to, in a curly bracket, here I have created a dictionary, isn't it? Dictionary which stores the values in terms of key and value pairs. So what is the key here? Name is the key. What are its values? That is Alice, Bob, and Charlie. Again, age is a key. What are its values? The values are 25, 30, and 35. So this is basically a dictionary. And after that, from this dictionary, I am creating a data frame. So when I create a data frame, you will find the values in terms of rows and columns. So how to create a data frame? You just need to use the object of pandas. Then you have to call the function from that pandas library, that is data frame. And to that data frame method, I need to provide a list, or I need to provide a dictionary, or I can provide a tuple. So here I am provided the dictionary. So from this dictionary, this pd.dataframe will create a data frame. After that, if you want to print the content of that df, you can print with the help of a print statement, like here I have done here. So after that, if you want to perform the operations on the data frame, such as finding out the mean age, finding out the youngest person, that we can do it with the help of the functions which are present in that df, that is the data frame. So now here I want to find out the mean age. from this data frame. So for that, I can say mean underscore age is equal to df is my data frame name. Age is the key, isn't it? Age is the key. I want to find out the mean age from the age. So that's why here I have provided the age, so that from these values of age, that is 25, 30, and 35, the mean function will find the mean value from these three different ages. So this will give me the mean age. After that, here I want to find out the youngest person name. So for that, here I am providing the name, so that the system, so that this function can find out the youngest name. But for that, I need to provide the age as well. So I am providing name as well as age, and from this age I want to find out the minimum age. That is idx.mean is a function which will give me the first occurrence of the minimum age from this total age, that is 25, 30, and 35. So idx mean will give me the index value of the minimum age. After that, I am extracting the minimum age values name from the name key. So if I get here, what is the minimum age? That is 25. So who is 25? That is Alice. So now this will give me the name as, say, Alice, as the Alice is the youngest one. So after that, I'm just printing the mean age and the youngest person. So if I execute this, you will see the output. That is, first here I'm printing the data frame. All the values are printed here, as you can see here, Alice, Bob, and Charlie. Now I'm printing the mean age. What is the mean age? That is 30. And what is the, who is the youngest one? That is Alice. So if I can change the values, now I am changing the values. I'm changing the age of Bob, say from 18, so from 13 to 6, or say 18. So now you'll find that Bob is the youngest one. So I'm executing here. So now you can see here, youngest person is Bob. So this is how we can create a data frame from the pandas library, and we can perform some operations on that data frame. I hope you understood this. Am I clear with this? Guys, is it clear up to this point? Creating NumPy, how to create NumPy, how to create a data frame. Is it clear to you? Any questions, any queries? Please go ahead. Nagraj, Alfia, Solomon, is it clear? Yeah. Any queries, any questions? Guys, am I audible? It is clear, sir. Nagraj saying it is clear. What about Solomon? Solomon, is it clear to you? Alice, is it clear? Alfia Khan, I hope it is clear to all of you. If you have any queries, any doubts regarding this, you can put your queries, your questions in the chat box so that I can address. So this is about NumPy and this is about the pandas. Now let's move on to the next.
क्लियर है क्या नहीं पूछ रहा है पर्सनली.
Yes, sir.
Hello.
क्या
I think somebody is not on mute. Please mute yourself. So the next concept is the data cleaning. How to perform data cleaning. Guys, data cleaning is very, very important when you are performing data analysis, or when you are building a model. So cleaning data, pre-processing are very, very important aspects. Whenever you are performing analysis, whenever you are building the model, your data first need to be cleaned. It should be clear, it should be accurate. There should be no missing values, there should be no anomalies, and all your values are numerical one. So before actually building the algorithm or selecting the model, whatever data that you have at your hand, it should be clean and clear in terms that it shouldn't have blank rows, empty rows. It shouldn't have duplicate values. It shouldn't have any exceptional values, that is anomalies. All values, all numbers, all the data should be in the same range. So from that perspective, we need to perform some operations so that we make sure that my data set is, is not having any missing values. There are no duplicate values and there are no empty rows in my data set. If it is, if in your database there are duplicate values, you need to find out and remove them. If you find out the empty rows in the data set, then you need to find out and remove those empty rows. If you find missing values, then there are different strategies which can be used for handling the missing values. You can fill up the missing values by using mean, mode, median, or you can simply remove those rows which are having missing attributes. Again, in your data set, if you are having the data in a textual form, say for example, if I'm having the data about the gender, that is, if it is male, I'm having M. If it is having female, I'm having as F. But here, when you're performing the data analysis, the data should be presented in a numerical form. So I need to convert the data from this categorical into a numerical one. I need to reshape the data so that data analysis can be accurate. Rather, performing the data analysis, in order to perform the data analysis, your data should be present in a numeric one. Then only we can extract the insights, because here we are using mathematical operations, we are using the mathematical functions, isn't it? So how a mathematical function will work on the textual data? So we need to convert that textual data into numbers. That is called as transforming the data, reshaping the data. So all these activities comes under the data cleaning, or data, we can say data pre-processing rather. We are pre-processing the data, we are making the data ready for the purpose of analysis. So when you are making your data ready for the purpose of analysis, you need to make sure that your data set should not contain empty rows. Your data set should not contain duplicate values. Your data set should not have missing values. Your data set should not have exceptional values. Then only the analysis, the predictions that your model will give you, it should be correct. That is the main objective. That is the purpose. That is the objective behind this data pre-processing activities. Whatever insights, whatever meaning that the model is going to extract, whatever prediction the model is going to give you, it should be accurate. But when it is possible? When your data is pre-processed, when your data is accurate from these all aspects. So that's why data pre-processing is very important. And in that, we have many activities I need to perform, like say for example, removing the duplicate rows, removing the empty rows, handling the missing values, and handling the exceptional values, that we call it as anomalies. So here, with the help of the pandas, we can perform some data cleaning activity. So it involves the task like handling the missing values, removing the duplication, converting the data types to numeric one. Like I said, that converting character data type to numeric one to ensure the data accuracy and consistency. So for example, first we need to import pandas as PD. After that, create the data frame like we did in the last example. From the dictionary, I am creating a data frame with the name that is df. Now, as you can see that I want to remove the rows with the missing values. So now here Alice is having value 25, Bob is not having the value. And again here in the name, I don't have the name for the third person and I'm having the age for that person. So here it means that I need to find out the missing values. So here are some missing values. How you can find out the missing values? Just by calling the function that is drop na. Drop na is a function which is defined in the data frame. So now I can drop the rows which are having, or drop the values which are having missing. The values don't have. I'm having the missing values. As you can see here, Bob is having a missing value. And again, 35 age is having a missing value. So this kind of data is not recommended. So here either you need to fill up these values by using some strategies like finding out the mean median of these two values and you can fill up the second value, or simply what you can do here, you can simply delete those rows having the missing values. So it depends on the strategy how you can handle the missing values. But here I am selected to drop the rows which does not have values. So how I can find out? By just calling the drop na. Drop na is a function which is defined in the data frame. So just by saying df.drop na will ultimately automatically it will drop, it will remove, it will delete the rows which does have missing values. So now I can print cleaned data frame. Now if I say print df.cleaned, so what I'm getting here, I'm getting only Alice as a 25. Bob is having a missing value, and again 35 is having a missing value. So that's why these missing values rows will be simply get deleted. So as you can see here, now I will change some values. Say here Bob is having a value. I will put the value for Bob, for example, say 35 or 34. So now we can see that now Bob is also having, is been displayed here. So now Bob, Alice and Bob both are having the values. So now what I will say here, I will put another name here. So for example, say Sachin. I will say here a Sachin. Now for Sachin, I am saying as none. So Sachin is having a missing value. So that's why now Sachin will not get printed. But now if I say, if I give the value for Sachin as well, then there is no missing values. So all values will get printed here. So this is how I can remove the rows which is having missing values by simply calling the drop na. Drop na is a function which will automatically find the rows having missing values and it will simply remove those rows having missing values. So this is how we can perform one of the operation, that finding out the missing values and how we can clean it up. Now the second thing again that is also important, that reshaping the data, encoding the categorical variables and scaling the features for machine learning. Means what? For machine learning algorithm or for data analysis, it is very important that you need to convert, you need to encode the categorical variables to numerical one. Category means what? Which are present in categories, male, female, isn't it? So it's a categorical data, but I need to convert into numerical one. Again, for scaling features, I need to scale down, I need to make sure that all the data, all the numbers for a particular column should be scaled, should be in the same range, so that the mathematical functions or your algorithm will correctly predict, will give you the correct predictions. That is very important. So, data transformation, when I say data transformation, which includes the task like reshaping the data, encoding the categorical values, and scaling the values for machine learning algorithms. So now how we can transform the data? As you can see here, we need to import pandas as PD. Again, I need to import one more library, that is from sklearn.preprocessing import standard scalar comma label encoder. So why this standard scalar is? The standard scalar is used to scale down your values. Means what? To bring your numbers into a same scale, into a standard scale. So that's why, and those functions are defined in the standard scalar, and from that standard scalar I'm importing, that is standard scalar from sklearn.preprocessing, I'm importing the standard scalar library, and again I'm importing the label encoder, so that I can convert the categorical variables into numbers with the help of the label encoder. So here I have imported two more libraries, that is standard scalar and label encoder. Standard scalar is used for scaling purpose and label encoder is used for encoding the categorical variables. So just go on and do it. Again, the first thing, I have created a dictionary here, and from that dictionary I am created a data frame. After that, I am printing the data frame once I have created it from the dictionary. Now, the next thing is that I need to create an object of the label encoder by calling the label encoder function. So here I am creating the label underscore encoder object by calling the label encoder method. So now I can use this label underscore encoder to convert to categorize the convert the categorical data to a numerical one. As you can see here, df is my data frame name. Category, what is category? As you can see, that category is ACB. So this is categorical data, but categorical data is not going to provide you a real scenario. It will not going to give you the real idea. Categorical data for data analysis. Data analysis requires the data in numbers. So categorical data will not suffice. So here I need to convert this categorical data into numerical values. That I can do that with the help of the encoder method. So first thing is that I need to create the object of encoder with the help of label encoder function. Now I can use this label underscore encoder object, and I can convert the categorical data, that is A, B, C, into numbers. How we can do that? Just specify the data frame. What you want to convert here? I want to convert the categorical data which is present in category attribute is equal to label underscore encoder dot fit transform. What you want to transform? I want to transform the category. So now the category, that is A, B, C, will be converted into numbers, isn't it? That is 1, 2, and 3. Since I'm having only 3 categories, that is A, B, and C. So now A, B, C will be converted into 1, 2, and 3. So this is how I can convert the categorical data to numerical one with the help of this label underscore encoder dot fit underscore transform. Next, I'm having the data, that is, you can see here values as 10, 15, 20, 25, and 30. So this is not in the same range. This is not in the same scale. See that we need to understand, if the data is not in the same scale, then your machine learning algorithm will not predict the correct predictions, will not give you the accurate results. So for that, the data, whatever data that you are presenting, whatever data that you are working with here, it should be scaled in the same, it should be standard in terms of scaling. So it means that the range of data should be in the same scale, isn't it? But here it is not in the same scale. So how to bring it into a same scale? By using this scalar function, that is scalar dot fit transform. But before that, I need to create the object of this standard scalar with the help of standard scalar function. So if I say here scalar is equal to standard scalar function, now I have the object of standard scalar. I can apply that scalar dot fit transform on the values, as you can see, that 10, 15, 20, 25, and 30. So now these values are being transformed, they are reshaped, they are bring down in the same scale with the help of this function, that is scalar dot fit underscore transform. I am specifying which column that I want to transform, that is values, that is 10, 15, 20, 25, and 30. So now I can print both, that is the categorical values which are transformed from the categories like A, B, C into numbers. And again here I have reshaped the values by using the standard scalar. So now if I execute this, you can see the result of this code. As you can see, this is first, here I have printed the DF. This is the first output. Now as you can see here, category, first thing here I have printed the data frame as it is. As you can see, AB, AC, ABD as it is, values are again as it is, since I have just printed the data frame. But after that, once I perform the transformation and standard scalar, again I have printed it. Now you can see that the output is entirely different. Category is what? Category, as you can see here, starting with 0, A for 0, B for 1, and C for 2. So now the category is been changed from A, B, C to 0, 1, and 2. And again, you can see that the values which were present in original as 10, 15, 20, 25, and 30, now we can see that they are bring down in the same scale. That is, as you can see, all the values are now in the same scale. So this is very, very important. Means what? In order to have a correct predictions, your data should be scaled in the standard one. And that can be possible by using this standard scalar function. So this is how I can transform the data. So transformation means what? Transformation means encoding your categorical data into numerical data and scaling your features for machine learning algorithms, bringing your data in the same scale. That is very, very important. If your data is not in the same scale, then whatever predictions, whatever insights, whatever extractions that your machine learning algorithm has given to you, they cannot be accurate. So for that, your data should be in the same scale. All the values, all the attribute values should be brings down in the same scale, and that is possible with the help of this scalar. And encoding the categorical values can be possible by using the encoder, such as the label encoder or the label encoder function. So this is how I can transform my data. I hope you understood this.
Sir, can
Yes.
you explain again the scalar?
Which one? This one?
Yeah.
Scalar.
Yes, sir.
See that what are the values here? We are having the values like 10, 15, 20, 25, and 30. Now tell me that whether this data is in the same scale. Is it in the same scale?
Yeah, I mean scales in the sense of,
In the same range. It's not in the same range, isn't it?
yeah, sir.
In terms of mathematics, this data, these values, that is 10, 15, 20, 25, 30, they are not in the same scale. So for a mathematical function to work, to give you the results accurately, the data should be bring into standard scaling. So the scaling of your values, numerical values, should be same. So how to bring that? To bring that, we can use this scalar dot fit transform. So after that, you can see values. The values now, I'm having the values as 10, 15, 20, 25, and 30. Now after scaling into a standard scaling range, you can see that all the values now are in the same scale. This is in terms of mathematics. So now in terms of mathematics, these values are in the same scale. They are in the standard scaling. Then only your machine learning algorithm can work accurately and give you the predictions accurately, or whatever predictions that your machine learning algorithm will give you, that will be more accurate. So just if you want more information on scaling, just go to the internet and search for the scaling of the data or the numbers or feature scaling, so that you will understand more about what is the importance of scaling the features. I hope I have given I have solved your query. Whoever is this? Am I clear, guys? Is it clear?
Yeah, sir, it's clear.
Yeah. So again, the time is over, but before that, I would like to give the feedback form for this session, and I request all the learners in this session to give your feedback so that we can work on it. So before I could end this session, I know that again in this session, I could not complete all the aspects that which I have thought of covering it, but don't worry, I will cover it into the next session. But before I could end this session, I am giving you the feedback form, the link of the feedback in the chat box. So I hope
university overfeed and sober.
I think somebody is not on mute. Please mute yourself. So this is the feedback link. I hope it is visible to all of you.
Yeah, I don't see the form. So
thank you guys. Because of the time restriction, I need to conclude here.
Now go fill this form. Yeah, I'm not going to fill out.
So I conclude the session here. Thank you everyone for joining this session. Till we meet the next time, it's a goodbye for now. Have a great day ahead.